Welcome back, everyone, to another deep dive. This time, we're going to be looking at 3D modeling. Well, not just 3D modeling, but the future of it, with this technique called Gaussian splatting. And I know it sounds kind of intimidating, but trust me, the possibilities are pretty amazing.
Yeah, it really is game changing. Like, imagine being able to create these really complex 3D models as easily as you generate images with AI today. That's the kind of potential we're talking about here.
Yeah, and that's what is so cool about this. We're diving deep into a paper called DiffSplat Repurposing Image Diffusion Models for Scalable Gaussian Splat Generation. And to put it simply, it's basically exploring how to use all that AI image generation power, that stuff that makes those crazy text-to-image things you see online, to make 3D objects.
And what's really cool is it uses what AI already knows about the world, like from looking
Yeah.
at millions and millions of images. So instead of like starting from scratch trying to teach an AI 3D, it kind of adapts what it already knows.
Right, right. Okay, so before we get too far into this, can we break this down a little? Like, what exactly is Gaussian splatting? I keep thinking like paint splatters, but I'm assuming it's got to be more complex than that.
Well, you're not wrong about the visual part. So instead of making 3D objects out of solid blocks like those voxels, it's more like using millions of these tiny colored points scattered in space.
Mhm.
And each of those points, or splats, has its own, size, shape, and color. And together they can make some really detailed, complex 3D stuff.
So it's kind of like a pointless painting, but like in 3 dimensions.
Yeah, exactly. And that's actually one of the reasons 3D Gaussian splatting or 3D GS is getting so popular. It's a really efficient way to represent 3D, which means you can make high quality visuals way faster than some of the old methods.
Yeah, that makes sense. I mean, speed is kind of essential if you're trying to build like a video game or a VR experience where you need things to load quickly. So, okay, so if this technique is so great, why isn't everyone just like whipping up these 3D models with AI already? Like, there's got to be some hurdles.
Oh, there are definitely challenges. One of the big ones is that there's not as much data for training AI to work directly with 3D. You know how we talked about those massive data sets for AI image generation? Well, we just don't have that same amount of 3D stuff to train with.
So it's like you're trying to teach someone to sculpt, but you only give them a little bit of clay to work with.
Exactly. And even when you try to like piece together 3D info from a bunch of 2D pictures, it can be messy. It's like, trying to solve a puzzle, but the pieces don't quite fit right. So you end up with inconsistencies, things that don't line up.
Yeah, that's what I was wondering about. It seems tricky to make a good, consistent 3D model from just 2D pics. So how does this DiffSplat thing get around that? You mentioned it uses pre-trained models. Does that mean it's like tapping into all that image data you were talking about?
You got it. That's actually the genius of it. It takes advantage of all that knowledge that image AIs already have. So instead of teaching a new AI from scratch, it basically adapts what it already knows about 2D.
That's pretty smart. But like, how do you even teach an AI that's used to looking at flat pictures to suddenly start thinking in 3D? That seems like a big jump.
It is, and the paper lays out a few key steps. First, they make this really structured data set from a bunch of 3D objects. It's like converting a 3D model into this set of blueprints that the AI can understand, like laying it all out nice and neat.
So they're giving the AI a cheat sheet, basically.
You could say that. And then here comes the really cool part. They use these things called variational autoencoders, or VAEs.
Okay, now I'm lost. What are those?
So think of them like specialized translators. They take all the information about those Gaussian splats, the size, the shape, the color, the way they're facing in space, and they turn it into a language the AI gets.
So it's like taking a really complicated technical manual and rewriting it in plain English.
Perfect analogy. Those translated bits of information are called splatlatents, and they're kind of like the bridge between the 2D world of pictures and the 3D world of objects.
That is fascinating. So through these splat latents, the AI can start connecting what it knows about images to how 3D things are actually built. But how does it actually learn to make those objects?
All right, so this is where the real magic happens. DiffSplat actually uses two types of training. There's the regular image diffusion loss, which helps it find patterns in those splat latents. And then there's this special 3D rendering loss.
Hold on, break that down for me. What's that second one do?
Well, it basically forces the AI to think about how those splats would look from different angles. That way, the final 3D object is, consistent. It'll look right no matter how you're looking at it. Remember those inconsistencies we talked about before? Well, this is how DiffSplat avoids that.
That's so clever.
Yeah.
So they're not just training it to see individual splats, but like to understand how they all fit together to make a whole 3D object.
Exactly. And this, using both types of loss, is one of the big reasons DiffSplat is getting such good results.
Okay, so tell me more about these results. Can DiffSplat actually make like really good 3D models from like just a text prompt?
It can, and the results are pretty amazing. Like, they tested it with both text prompts and images, and it consistently did better than other methods out there. And what's exciting is it's not just about, making A and Y 3D model. Displat actually scored higher on how well the models matched the prompts, Andy, how good they looked visually.
Right, because it's one thing to make a 3D blob, but it's another thing entirely to make something that looks good. A and D is actually what you had in mind.
Exactly. And if you look at like figures 3 and 4 in the paper, you can really see how detailed and intricate these models are. They even managed to reconstruct like a whole 3D scene from just one photo. It's kind of wild.
Wow, that's incredible. Like the potential for that is just wow. But okay, what about control? Like what if I have a very specific thing in mind? Can I like guide Displat to make exactly what I'm thinking?
That's where it gets even cooler. The paper talks about using DiffSplat with this thing called ControlNet. So imagine you have like a set of blueprints that guide the whole 3D generation. You could use sketches, depth maps, even just basic outlines to kind of influence the shape, the textures, the style of the final model.
It sounds really powerful. So it's not just random. You could actually like steer the AI.
Exactly. Think about what that could do for like creative workflows. Instead of starting from nothing, a designer could just sketch out their idea and let Displat do the heavy lifting, make it a full 3D model.
Yeah, that would definitely speed things up. But I'm sure even with all this amazing stuff, there are still some limitations, right? Does the paper talk about any challenges or where Displat could be better?
Yeah, it does. One of the main things they point out is that it's still tricky to turn Displat's 3D output into like those smooth, high-resolution meshes you see in video games or movies.
Wait, remind me what those are again?
Okay, so meshes are basically how you make those really smooth, detailed surfaces in computer graphics. Imagine a 3D object being built from a bunch of interconnected polygons. That's a mesh.
Right, right. Okay, so even though DiffSplat can get the shape and look right with the Gaussian splats, turning that into like a final refined mesh is still a work in progress.
Exactly. Think of it like, you have a beautifully sculpted clay model. It's got all the right shapes and everything, but then you have to cast it in bronze to get that super smooth finished product. So researchers are working on making that conversion process better, but it's still a bit of a challenge.
I see, that makes sense. It sounds pretty complicated. The paper also mentioned something about adding physical-based material properties to DiffPlat. Can you explain what that means and why it matters?
Sure, it's about making the 3D models even more realistic.
Yeah.
So instead of just saying, okay, this is the shape and this is the color, imagine being able to say, this robot is made of shiny metal, or this table is made of old wood.
Oh, I get it. So you could not only make things that look realistic, but that actually behave realistically in like a virtual world.
Exactly. That would be super useful for things like product design, where you need to simulate how materials work together, or just making those super immersive VR experiences.
We're getting closer and closer to virtual reality being like indistinguishable from real life. Okay, but what about Displat itself? Like, where does it go from here? Does the paper talk about any other cool stuff that might happen with this tech?
Oh, yeah, it does. And this is where things get really interesting. I think one of the most exciting things is that Displat can take advantage of all the cool stuff happening in the world of image AIs, like think personalization, faster generation, even like incorporating feedback from users to improve designs. All that stuff can potentially come to 3D modeling too.
Wow, that is mind-blowing. So we could maybe train Displat to match our own style, or generate those super complex 3D models in just seconds. The possibilities are kind of endless, huh?
Yeah, they really are. And the paper even touches on this idea of training Displat with like tons of video data. Imagine the AI learning not just from pictures, but from videos. So it's seeing movements, changes in lighting, all these interactions between objects.
That's wild. You're right. The possibilities are pretty much endless. Okay, but can we back up for a second? I still kind of want to unpack those slat latents you mentioned earlier. It's hard to wrap my head around how the AI makes sense of them, to actually build these 3D things.
That's a really good point. Those splat latents are kind of the key to how DiffSplat connects 2D and 3D. And yeah, I think digging into how they work will definitely give us some of those aha moments.
Okay, so let's get into these mysterious splat latents. You said they look like abstract art, but how does the AI actually, like, figure those weird patterns out to make 3D?
Yeah, it's pretty wild, right? So if we look back at Figure 7 in the paper, it shows how those splat properties, things like their color, how far away they are, how transparent they are, even which way they're facing, it's all encoded into these grid-like pictures.
I'm looking at it again now, and yeah, it does look kind of like abstract art,
Yeah.
but I still don't really get how that turns into an actual 3D model.
Okay, so imagine each grid is like all the info for one splat all packed together. To us, it just looks like a bunch of colors and shapes, but for the AI, it's like this visual language, like it's full of meaning.
So the AI is learning to, like, read these grids, kind of like how we learn to read sheet music.
Exactly. And what's even crazier is that these grids, they actually have some similarities to how regular pictures represent things, like color gradients and edges. It's almost like the AI is tapping into some fundamental visual language that works for both 2D and 3D.
Whoa, that's kind of deep.
Yeah.
But how did they even figure out that image AIs could do this? Was it just a happy accident, or was there, like, a plan?
I think it really shows the power of just observing things and being curious. Researchers noticed that these image AIs, especially the ones trained on tons and tons of images, were already pretty good at picking up on 3D cues from 2D pictures. Think about it. Like, even we can usually tell how far away something is in a photo, even though it's just flat.
Right. Yeah, our brains kind of fill in the blank. So you're saying these image AIs were already showing signs that they could kind of understand 3D?
That's it. So what DiffSplat does is it takes that ability and like supercharges it. It trains the AI not just to see the 3D info, but to actually create it using those splats and those splat latents.
So it's like they unlocked a hidden power in these image AIs. Makes you wonder what other cool stuff they might be able to do, right?
Yeah, absolutely. And it really speaks to this bigger idea in AI research, where you take what we've learned in one area and apply it to something totally different. Opens up a whole new world of possibilities.
It really is mind-blowing.
Hmm.
So as we wrap up this deep dive on DiffSplat, what are the big takeaways you think people should remember?
I think the most important thing is that DiffSplat it's really changing the game for how we think about making 3D stuff. Using the power of those 2D image AIs, it's making 3D modeling way faster, easier, and more accessible to everyone.
It's like democratizing 3D design, right? It's not just for specialists anymore. Anyone with a cool idea can potentially use this to, like, bring it to life.
Exactly. And as the technology keeps getting better, I think we're going to see some truly amazing stuff in all sorts of fields, like video games, VR, product design, even things like scientific visualizations.
Yeah, it's definitely an exciting time to be watching all this happen. So if anyone's interested in learning more about DiffSplat, like seeing it in action and stuff, where should they go?
Well, the authors of the paper, they actually put a link to their website right in there. You can find more examples, all the technical details, even more about their research process.
Awesome. We always encourage everyone to, check out the source material. That's where the real learning happens.
For sure. The more we explore and question, the more we discover, and the more we can push the boundaries of what's possible.
That's a great thought to end on. So until next time, keep those minds curious and keep exploring.